Let Rx denotes the vector space of real polynomials. Let D is defined from Rx to Rx denote the map. DF means D, this mapping D sending image of F as derivative of F. For all F, then D is 1 1, D is on 2. There exists a map E from Rx to Rx so that DE is F, and this is true for all F. And option D is there exists a map E from Rx to Rx so that EDF is F for all F. Now come to these option one by one. As we know that Rx is a vector space, and this is also given, this is a vector space of all real polynomials, and D is defined from vector space Rx to Rx. You can check this is a linear transformation or not, but I am not verifying here this is a linear transformation or not. And D is sending image of F as derivative of F. This is true for all domain points or domain inputs. Now we have to check D is 1 1 or not. Means if how to check 1 1, if we have x1 x2, then their image is f of x1 and f of x2. If these two are same, then their images must be same. Now consider function or two inputs, x1 is 2 and x2 is 3, x1 is 2 and x2 is 3. Then image of these two, as these are constant function, you can consider this is as f1 or f2. So these are constant function, and derivative of f1 is 0 and derivative of again f2 is 0. We have two different input but their image are same, so f is not 1 1. So option A is eliminate here. D is onto, as derivative of f is again a polynomial in x in one variable, so we have to check this D is onto or not. It means we have to consider an element in codomain and their image should be in domain. Whatever the image or point in codomain, their pre-image should be in this one, because this is nothing but same vector space. If some polynomial in one variable is not there, then its may not be. So whatever or what types of polynomial or possible polynomials this Rx have, this Rx also have. So pre-image of this all points of codomain is avail in domain. So D is onto. This is perfect, and this is nothing but antiderivative. Antiderivative will present in domain. Antiderivative in domain and its derivative in codomain. Now option C, there exists E from Rx to Rx so that D, E, F, here F should be there, something is missing. E, F is F for all F. Now we have to check there existence of this map E from Rx to Rx. We are checking existence or not, such that E of DF is F is true for all f as domain. So suppose f is any polynomial, then this is input for e. So its derivative of f as input, then when we apply e, it is nothing antiderivative because making f same. So when we take a derivative of an input, then if we integrate that one, after integration we will need to add some constant, some constant. So derivative of f, suppose f1 is constant function and f2 is 3 and their derivative is 0, we have 2, we have 0, or we have 2 f1 and there e of 0, suppose this e will send 0 as a antiderivative, any constant value, suppose this is c1 and e of 0 maybe c2. So existence of this edf is not well defined, so this option D is not perfect, and D of ef is f, this is true because whatever integration we take of f, then we need to add some constant, and whenever we differentiate that one constant, that will eliminate by derivative if certain initial condition we have. So derivative of ef is f, this is true in all cases, and this is antiderivative of f. So only option B and C are true here.